The whole goal of this talk is how to make use of this simple system that you saw yesterday. Application of what we call FDT for monitoring recreational water using Clostridium perfringens as a marker of sewage contamination. Number one, Clostridium perfringens, precisely a pathogen, is a very active organism, and so it grows very fast. It's one of the fastest growing organisms we know. It's only 8.1 minutes per generation, so it grows very, very fast. E. coli is 20 minutes per generation. It's probably longer to have a colony. Originally, when I started this work, I was using the old German method of having a thin agar layer at the bottom of a petri dish, and then put a little petri dish in, and then a little petri dish in, and that would be the German way of having a thin layer of agar and quite anaerobic. It takes a lot of manipulation. So I saw two tubes one day in the laboratory, and I said, well, if I put a small tube into a big tube, then I can form a film. Then that's how we think about this double tube method. Is very, very simple. As you see this slide already yesterday, all you have to do is to put the right amount of agar and put the right amount of liquid in a big tube, and put the small tube in carefully, close it up. This is as anaerobic as a $10,000 anaerobic chamber. It's much easier to use, and you can clean it up very easily. So I already showed this slide that in about 4 hours, actually, after you set up the system and put it at 40 degrees centigrade, you actually can see little black dots. You can start counting them. And then, of course, the longer you incubate it, the quality will be bigger. But if you want to have results or estimation of how many organisms you have in the water or food or whatever, you actually can get an answer in 4 hours. Okay, I will briefly talk about the contamination level that we developed after using this system. Dr. Fujioka is a professor in Hawaii. I went to work in his laboratory for a few weeks, and we developed this whole system there actually. They were very interested in swimming pools, swimming beaches, very important in Hawaii. If you have too much contamination, you have to close the beach. But the conventional method takes 48 hours. Have a sample, 48 hours later, close the beach. So we had to do it long. So we decided to do it in 4 hours. So I developed a method in Hawaii for closing the beach or open the beach in 4 hours. And then we worked for a while, and we found out that there are kind of 4 categories of pollution categories. Number one is in the food opportunity, there's no organism, that means it's less than 10 CFU per 100 ml, no contamination over the beach. The second category is 1 to 10 colonies in the double tube that we estimate is 100 CFU per 100 ml. Then this non-point contamination is still okay to open the beach. The third category, then they will start closing the beach. Hawaii is very important. If you close the beach, you're talking about hundreds of thousands of dollar loss through the swimming, things like that. So the category 3 is you have sewage contamination possibility. The fourth category is definitely close the beach. So this is a category that we use in Hawaii. If you want to study more liquids, the tube cannot handle more than 10 mils. So you can put a filter. This is called the isocrate filter, and you can filter the water through this grid. Then you can incubate it, and this grid can handle a lot of organisms. So if you have lots of contamination, this will be a very good strategy to use this isocrate system. We did some a lot in this type of work. We have to compare the conventional method with the new method before people will use the new method. Anytime we have a new method, you must compare it with the established method. And we did. And we used the membrane, the Clostridium perfringens method, and this simple FDT method. And we did a lot of work and found out that we have similar counts from stream water, sewage water, and when we put in Clostridium perfringens, we can recouple them. Right, so the first is comparative recovery of Clostridium perfringens by the Fung method versus the membrane filtration method. That takes a lot more equipment, a lot of materials to obtain the same data. So this method is very simple to use. And then we also study comparative recovery of this phage, which is the environment, polyphage, and then compare with the Fung method, the phage method. It's quite comparable in terms of the amount of organisms. Stream water they have low, sewage water they have high in both methods. Each water sometimes depends upon the regions. So this is how we establish that this simple method will give similar data as the conventional method, use a lot of material and much more expensive. We did a lot of work. We drove around the countryside, beaches and all over the place. So we did this Fung method and count the quantities versus the extrapolation data versus the EC phage and EC phage extrapolation data. And they came out very, very comparable. If there's no organism in Fung data, we have no phage there, etc. So this chart just shows you that the simple method that we work in the laboratory is comparable with the more established method that we use all over the world in terms of monitoring contamination level of the seawater. This is the effect of high temperature short time pre-treatment of sewage sample in the incorporation of phosphatase test, is the MUC test, to FE medium on the recovery efficiency of Clostridium perfringens using the modified Fung system after 5 to 6 hours of incubation. And the aerobic condition is you do the test, but you do not need any anaerobic environment because the test itself makes it anaerobic. And then we study sewage contaminated water and high temperature shock treatment of sewage of the two systems, and they are very comparable. And we also put some fluorescent compound in so that it's easier to read the quantities. So this fluorescent black quantity will really tell you that you do have a Clostridium perfringens in the sample. So it's a very simple test, but it's very powerful, giving you good information. Then we did a lot of tests on comparative effect of high temperature short time pre-treatment of sewage samples and incorporation of phosphatase test, the MUC test, with the SFP agar at TFC medium on the recovery efficiency of Clostridium perfringens using the membrane filtration method after 12 to 15 hours incubation in anaerobic chamber. So again, the information shows that the two methods work very well. And the blue fluorescent black quantities is very effective. You can see it very, very distinctly in the laboratory. And then we have this TSC plus phosphatase test. And we will compare it with the sewage contamination versus the high temperature treatment of the organisms we do not know to monitor and get a very good data of the simple, much simpler method. And we did run around Hawaii, which is a good thing to do with the beautiful environment. We went around the places and collect samples to test the number of organisms in the beaches. In that system, after the growth, you can actually count the organisms, but if more effective is put under the ultraviolet light, you can see fluorescence of the organisms. We also tested enterococci, which is also an organism as an indicator of pollution. And it came out, this is a Clostridium count, and there's a city, county, health department data, comparing with the water research data here, and they compare very, very favorably on the two systems. So CCH is a city county of Honolulu versus this more sophisticated research laboratory that we were working in. And then we did a lot of water testing. We studied different cases. We went all over the beaches, all over the place. And we collected a lot of water samples. We measured the salinity of the water. And we used the MPN of the anthropococci, which will show presence of contamination of fecal material. We also tested the Clostridium species. We studied the Clostridium perfringens. So we have 20 different samples of the spores. So of course, the spores will hang around for a long time, so it's important to know whether you have spores in your samples or not. And all these data show that they are very, very comparable with the conventional method, with this simple method of estimating or counting Clostridium perfringens. And then we also test the germination of these spores to find out how we can effectively recover them. So we found out that both the methods are very, very comparable. The Clostridium test using the double-tube system is only 4 hours compared with the conventional method. It takes a much longer time. We measure the effluent, and we measure all the systems during that period of time. And so again, we find that they are very, very comparable in terms of the numbers. So the question is, right now they are still evaluating, testing it to, if you want to make anything official, it takes a lot of more testing than just a laboratory do something. So we will be testing a lot compared with the city, county, health department, the Department of Water testing. So this is still a very, very active research work. If you all want to run this type of test in your laboratory, it's really quite simple. You just buy a big tube, a small tube, and these tubes are very easy to use and clean, and so it will be a very, very effective method for you to monitor the Clostridium perfringens in water, in food, and things like that. Okay.